Hello guys, welcome back to my YouTube channel. Today I'm going to solve day 29 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today I'm going to solve problem number 2962. Count subarrays where max element appears at least k times. Okay. So in this problem, we have given one nums array and one value k. Okay. So in this problem, we have to first of all we have to find the max element. Okay, and after finding the max element we have to create a sub arrays, and we have to make sure in that particular sub array the count of the max element should be at least k times. Okay, so we have given an integer array nums and a post integer k, and we have to return the number of sub arrays where max element of nums appears at least k times. Okay, so this is a problem given to us. So here example 1. So nums array k is equal to 2. Then see the expression, the output is 6. The expression says that subarrays that contains the element 3 at least 2 times are. Okay, so we have to create subarrays in which the max element 3 is at least 2 times. Okay, so this is one subarray 1 3 2 3, right? 1 3 2 3, this is one subarray, and then 1 3 2 3 3, this is one subarray. After that, this is also one subarray 3 2 3 3, and this is also one subarray 3 2 3, right? After that, this is also one subarray 2 3 3, right? And after that, this is one more subarray. So in total we have total 6 subarrays. Okay, so now let's understand the approach which we are going to use to solve this problem. So I am going to use sliding window technique. So here I have picked example number 1. So this is our nums array, and these are the index. So element 1 is present at index 0 1, at index 1 we have 3. Okay, so here first of all we have to find the max element. So what is the max element in our nums array? So max element is nothing but 3 in this particular example. After finding the max element, we have calculated the length of my nums array. So the length of my length of my array is 5 right now. And after that I'm going to use sliding window technique. So for that I'm going to use 2 pointers. One is left and one is right. So initially both left and right are going to point at this particular position. Okay, and after that I am going to move my right pointer one by one to the right side. Okay, so initially when my both left and right are at this position, so this is only sub array right now. So in this sub array the count, what is the max element? Max element is 3. So what is the count of this max element right now? So count of max element is 0 right now. So this is not a good subarray. Okay, we don't need this subarray. So what I'm going to do here, I'm going to move my right cursor to the next position. So my right cursor now reaches at this position, and in this subarray what is the count of my max element? So count of my max element is 1 right now, and so this is not a good subarray, so we don't need to consider this subarray. Then after that my R pointer reaches at this particular position, and right now what is the count of my max element in my subarray? This subarray. So right now count is 1, and this is also not a good subarray, so I don't need to consider this one as well. After that my R reaches at this position. So now see carefully. So when my R reaches at this position, so count of my 3 becomes 2 right now. So count of 3 becomes 2 right now. See, just see, focus on this subarray. Okay, so count of 3 becomes 2 right now, right? So this is a good subarray. Okay, this is a good subarray because in this subarray uh, it contains the element 3 at least 2 times, right? So this is good subarray. Now after that, if I include any element and it is going to start from left this position only, after that if I include this one, then this also becomes a good subarray. Okay, so what I am saying here, we know that 1 3 2 3 is a good subarray. We know, right? We know that this is a good subarray because in this subarray 3 is 2 times. Okay, then after that if I add here 4 or 5 or 6 7, I add anything, so all other are going to be good subarray. Okay, so see here, this is going to be good subarray because 3 is 2 times. Then this is also going to be good subarray because 3 is 2 times. This is also going to be good subarray. After that, because 3 is 2 times. This is also going to be good subarray because 3 is 2 times. Okay, because our left is fixed at this position, and after that when I'm going to move R, I can move R multiple times after that. Okay, every time I'm going to get the good subarray. Okay, because this count of 3 is fixed right now. After that, if I get 3 here, then count of 3 becomes 3 and we are good, because we need at least 2, right? So what I'm going to do here, I am going to store the answer in my result variable. Okay, so in result variable I am going to store the result as what is the total length of my subarray. Total length is n, and where is my r pointer right now? Okay, n minus r. So right now n total length of my subarray is 5 and r pointer is at this 3 index. So in the result I am going to add 2. Okay, so every time I am going to add the answer in my result one by one. Okay, so right now in this particular example 1 3 2 3 is 3 is our array. So I have found that this is a good subarray. Okay, because in this subarray we have count of max element as 2. If I include this 3 as well, then also it is a good subarray, right? So here I am adding 2 right now, right? I hope that you guys are clear why I am using n minus r here. Okay, because from this example it is clear that if we have found one good subarray, after that we are starting from this particular position only. After that, number of elements, okay, how many number of elements are there, we have to just calculate that starting from this position, and we have to just return the result, because these are going to be a number of subarrays. So in this particular example 1 3 2 3 4 5 6, so see, this is good subarray 1 3 2 3, so count is 1. After that, when I include 4, then one more count. After that, when I include 5, then one more count. After that, when I include 6, then one more count. After that, when I include 7, then there is one more count right now, starting from left. Okay, so total 5 subarrays. So okay, so from here we need to just calculate n minus r. N minus r. So I have added 2. So once this is done, now after that I don't have to move my r pointer. Okay, so now after that, let's move my left pointer. Okay, so initially my left pointer was at this position, so now I am going to move my left pointer to this particular index. So when I move my left pointer at this particular index, so I have to again check what is the count of my 3 right now. Okay, so there is no impact on the count of 3 right now, right? So what is clear right now, so from here also I am getting one subarray, right? Because in this particular subarray 3 2 3 3 2 3, we have the count of the max element as 2. Okay, and we need the count at least 2 times, right? So this is good subarray. Again, now I have to, where is my r? Okay, now my left is starting at this position. Okay, so 3 2 3 is going to subarray. Okay, so in the first step, here I am writing, in the first step we have found that 1 3 2 3 is a good subarray, and 1 3 2 3 3 is a good subarray. Now I am doing the second step, where my left is at this position. So here I have found that 3 2 3 is a good subarray. 3 2 3 is good subarray, and after that, how many number of elements we are getting? Because every time I'm getting any number, it is going to be good subarray, because the count of 3 is fixed starting from this left, right? So n is 5, r is still at 3, right? So I have to add 2 here. Okay, 2 plus 2 4. So here I have found 2 subarrays, 3 2 3 2 3. Okay, this is done. Now I am going to perform the third step. Okay, so now once this is done, after that my r is going my left is again going to move to next position. Okay, my left is again going to move to the next position. So now my left reached at this position, and now my count of 3 is going to be decreased, right? So now in this subarray, in this particular subarray, focus on this subarray, so count of 3 is 1. Okay, so when count of 3 becomes 1, so again I have to move my r pointer right now. Okay, so now I am going to move my r pointer to the next position. So now my r reaches at this position, and now focus on this subarray. Okay, so in this subarray, count of 3 becomes again 2, right? Count of 3 again becomes 2, right? So when my count of 3 becomes 2, so I have to write this subarray here, 2 3 3. Okay, and here I have to add in the result, right? So here what I'm going to do, add n is 5 minus R is 4, 5 minus 4 is 1, so here I have added 1. Okay, so this is one subarray. Okay, so now when I have found one subarray, so this one is showing that nothing but the number of subarrays that we have found till here. Okay, now after that again my left pointer is going to move forward. Okay, so now my left pointer is reaches at this position. Now focus on this subarray. So this is also good subarray because 3 is 2 times. Okay, this is fourth. 3 is 2 times right now. Okay, 3 is 2 times. So here this good subarray. So here again I have to add one more value that is going to be nothing but 5 minus r. R is 4, 1. Okay, so this is done. Okay, so I hope that you guys are clear. So again my left, after that again my left is going to move one step forward, and now when my left moves one step forward, so my left is going to reach at this position, and when my left reaches at this position, then it will see that there is only one 3. Okay, and count is not matching, so my R is trying to go move to the next position, but right now there is nothing in the at this particular index, so our loop will end and it will just return the result in the end. So what is the result? 2 plus 2 4 5 6, so 6 subarrays. So 1 2 3 4 5 6 subarrays, and these are the 6 subarrays, right? 1 2 3 4 5 6, so output is 6. Okay, so I hope that you guys are clear with this problem. Now let's write the code. Code is going to be very easy. Okay, I'm going to write the same thing. So first of all, we are going to find the max element. Okay, so for that I'm going to write int max element is going to be, let's take it as integer dot min underscore value. Okay, min underscore value. Then I am going to iterate over each element in my nums array. So I am going to use for each loop int num over nums, and I am going to update my max as math dot max num. Okay, this is done. So I have found the max element. Now after finding the max element, let's calculate the length of my subarray, my array. Int n is equal to nums dot length. Then I'm going to use my left and right pointer, and both are going to point initially to the 0 index, right? Int left is equal to 0, right is equal to 0, and I'm going to store my result in long variable because size is very big. Okay, so long result is equal to 0, long result is equal to 0, and I have to count the max value, right? Count max, so it is also 0 initially. Okay, so space complexity is going to be of n only. Okay, and then right while loop, in the while loop, while right is less than n, and inside this check if nums of left, if nums of right is equal to my max, then I have to just increment the count of max, right? I have to increment the count of max. Okay, and then once this is done, after that right while this max, if this max while this count max, okay, is equal to k, then in that case we have to update our result. Result is going to be nothing but result plus n minus right. Okay, this is my result, and after that we have to check if my nums of I, the value that I'm going to remove from my left, right, if it is equal to my max, then I have to decrement the count max, right, if this is the case. And here I plus plus, and while finishing j, okay, we have to increment our right. Okay, so here I am moving my left plus plus, and here I have to increment my right in the end of this while loop. Okay, so this is done, and in the end just return result. Okay, that's it. So I hope that you guys are able to understand today's problem. So okay, give semicolon here, run. If nums of I is equal to max, okay, let's see what's the issue here. If nums, okay, why I'm writing I here, if nums of left. So all the test cases has been accepted. Now let's submit the code. So our solution is accepted, and runtime is also very good, 4 milliseconds, and it beats 100% of users with Java. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye.